All right, so this is a live stream where I was asked um, to go over the CSE 465. I'm doing this as a live stream just as a convenient way to record a video without having to upload it later. If students are online now, I post it on Piazza and you can join. But mainly this is just to record the video. The question was asked about the second project. Goodness, I wish I had realized how many assignments I would generate at the beginning and organize this a little bit better. Those little half-point reading assignments. Um, so project 2 was what the question was about. And so the just a quick review. The project is on the GitLab server. And if I scroll down, hopefully we don't get dizzy here. I know the text is probably small, but the goal is to write a parser for this language called Lisp-ish. I spent about maybe 15 minutes during the last lecture going through it, but the question, I had a student comment that they just didn't know how to start. And so I was thinking that it was enough to say it's exactly the same as Lab 7. But let me be, a little bit more explicit and remind us you of what we did in Lab 7. Right? So you're writing a parser for a Lisp-like language. To get started, you do all this forking stuff. We know that by now. We've done 9 labs already. So the overview here is you're given a grammar, right? So in Lab 7, your grammar, so if I were to select this portion of the grammar, can I zoom in? Okay. If I were to select this portion of the grammar, this is written in BNF, and it contains only one eBNF rule. And this eBNF rule is pretty simple. As long as you can, so really this is going to repeat until the end of the file, you're going to try to parse the next S expression, right? So, just to kind of explain the grammar, you all know scheme. A program is just a list of scheme expressions, and a scheme expression can be an atom by itself. Like you can write the number 3 in scheme, and that would be, let me just here clear cd dot dot. Okay, just let me run scheme real quick. Scheme, right? So you could write the number 3 by itself, and that's an expression, and scheme will display its value, which is 3. So you can write an atom by itself. You can also, in scheme, you can write a string, I think. Yeah. So those are expressions by themselves, whatever, right? So an expression can be an atom. And for us, an atom is either an identifier, an integer, a real, or a string. So if I were to write the word apple, that's also a valid scheme expression. However, how do I get out of that? I can't remember. It's been so while, so long. Since I use scheme. Okay. How do I clear those? Give me, oh goodness. How do you clear the errors in scheme? We're going way back into the beginning of the semester. Scheme interpreter. Inspect, use debugging system, add the program, debugger, debugging aids. Okay, hold on a second. Okay, unbound variable, that's exactly what we did. How do you exit the scheme debugger? All right. Did I just press Control C before? I think that might be what I did before. Is there a quit? How do you quit the scheme debugger? Type Q to quit. That's what I did. Oh, I see. Okay. So, debug. It lies to me. Did I hit Control C? Control C. Okay, that's how I did it. I hit Control C twice. Of course, this happens in the live stream. Maybe I can trim it out. Okay. So, all right. So, of course, typing foo didn't work. All right. So I'll do it again just to remind us. So I typed 3, it works. You know, I can write 2.4. Those are all atoms. I can type an identifier that is also an atom, but it'll cause an error. And the reason that it causes an error is because foo has not been defined. I can also write an S expression, which is a list, right? So I can define foo to be, this is foo. And now I can type foo, and that is a valid S expression, right? So the project is somewhere. Too much. So the project is that you have an S expression, which is either an atom by itself or a list, right? Now a list can be the empty list, or in parentheses, you have a sequence of items. So a sequence is represented either as an item by itself or as sort of a head item followed by a tail sequence, right? So, and this is in our mini Lisp. The real Lisp is a little bit more complicated, but not much. And an atom, of course, can be an identifier, an integer, a real, or a string. So for this particular project, I gave you regular expressions in order to parse them. So there's 2 things that you can do, right? So you can you can make a state diagram based off of these regular expressions, or you can try to actually use regular expressions in C#. Right. So again, I'm expecting that junior level students can make sense of the regular expressions and read the explanations in Regex 101 as described in class. honestly, if I don't want to make you feel bad, but if that's not the case, I'm a little bit disappointed. So, but I don't think that's what's tripping maybe people up. I think what's happening is there's like a psychological problem of you're afraid to start, right? So, my advice to the people who ask this is look at Lab 7. I'll open up the code again, and we can get going. But really, these regular expressions correspond to a state diagram. You know what? I'm going to help you out here. I'm going to draw that state diagram, at least a little bit of it. I probably won't finish it because, I mean, come on. But let's, maybe Zernal. Looking for a drawing program that I can use to draw a state diagram. So here I have a drawing program, and I'm going to draw the state diagram that corresponds to this grammar. All right, so I am going to take this grammar, and well, you know what? I'm going to copy this. Let me see. Windows Shift S. There we go. I'm going to copy this, and I'm going to pop it into Zernal. There we go. This is just a note-taking app. So there is the regular expression, and there we go. I can move that up and to the right. Okay. So then we can begin to look at what the state diagram would be. All right. So wake up my tablet. I've got a tablet here. Don't use it very often. Okay, so let's look. So the idea here is that we're going to be greedy when we parse these things. And so we have a start state. And during the start state, what we're going to do is we're going to skip any white space characters, right? So any white space characters. So that would be space or new line, anything where car.is white space would return true. Right, so in your code, you're going to have that string, and you're going to have a current character, and you're going to keep advancing your current character index as long as the current character is a white space character. Now, let's look. The highest priority token here is an integer. Right? So for an integer, we are going to have, we might have a plus or a minus. So I'm going to draw this transition, and I'm going to put plus or minus as characters for which I would take that transition. And then followed by the plus or a minus. So after I read that, I could also read a digit, 0 to 9. It just represents the range of digits, 0 to 9. And then once I've read at least one digit, then I am potentially a valid integer. There we go. So you do 2 circles there to indicate that that is a potentially a valid integer. Now, as long as I'm in there, I can continue to read numbers 0 to 9. Any edge that I don't draw. So for integer, there's sort of like the edge that I don't draw that brings you back to the start state. And that's sort of like on the empty string. And then what you would do then is you emit the token, right? You yield the token. However, you're going to add it to the list, right? So this would be add the token. In fact, let me write that. Be very explicit so that you can, maybe you can translate the English into code, right? So you're going to add the token to the list that I gave you, right? There we go. So then, yeah, so this, you see you read a plus. Now this here, there's a question mark with that, which means, so this of course is a group operator on regex 101, and it's a non-capturing group. You don't need to worry about what that means. But the idea here is that you can either have a plus or a minus inside of those parentheses, right? So, and then that question mark means it's optional. And so since it's optional, you can actually skip over that plus or minus straight into integer if you just read a 0 or a 9, right? So this is the state diagram that could parse just integers. And, you know, it would be able to deal with strings that had 33 and then some spaces and then 178 and then some spaces. You know, strings like that, it would be able to tokenize just fine, right? So that's what we've got right here for integers, right? So coming back, there's also real numbers. So a real number begins the same as an integer, right? Except for that it's possible to, from this state, just have no 0 in front of it, but just a decimal point, right? So I'm just going to draw an arrow from here on a decimal point. And that'll take us to that you're parsing. Well, you still need to, after that, parse another integer, another number, 0 to 9, because you need to parse at least one. There's a plus sign there, right? And then at that point in time, you're a real, according to this state diagram, right? And so from here in an integer, again, you could read a decimal. Well, you could read one number. You could read a whole integer, and there, if you get a decimal point. Okay, so it's clear you can't have two arrows coming off of the same node with the same character, right? So that's kind of like, I think that's pretty obvious, because how would you write the switch statement, right, that we talked about in class, right? So you can't have two arrows coming off the same state with the same character, but we don't. So we're good. So now we can handle, let's just check this off. We handle integers and we handle reals. So for a string, okay, so if it's a string, it's going to be a quote character. And then here we have a non-capturing group in those parentheses. And there's a slash. So two slashes in a regular expression mean a slash character, right? So if we read in a slash character, and then that's a quote, right? So this is, you couldn't type this into C++ as it is. You'd have to escape these quotes, but you know, here they're just not escaped. So that's a quote character. All right. So after reading a slash, you can read a quote character, and you would still be a string, right? So there we go. There's the quote, and we're back into the middle of the string. Or you could read any other character, right? So for any other character, I'm just going to write any, and we just assume that it's any character that's not listed. Sometimes I would put a star there. Oh dear, I didn't realize I had an appointment in 10 minutes. Okay, so I'm going to have to pause this live stream, or stop this live stream, and then pick it up in a second part. All right, so any character except for a quote, right? Because if you encounter another quote, so just be here, any other, you just stay in there. And on the other quote, at that point, and only at that point, have you parsed a string. Right, so now we have a string, and this should match things like hello, or say, in quotes, say, and then you can escape the quote, cheese. And you can escape the quote, and then finally you can close the quote. Put something there, right? So those would be examples of strings, right? So let's see. I've got 10 minutes. So ID goes like this. So from start, you can read anything that is not a space or a quote or a parentheses. So I'm just going to put not white space, quote, left parenthesis, or right parenthesis. There we go. And then you have to read at least one, because that says there's a plus operator there. And then again, as long as you continue to read things that are not white space, quote, left parenthesis, or right parenthesis. Okay, and then there is an ID. That's an accept state. A literal. So we've got two types of literal. They're just a left parenthesis. I had to escape them because they mean something, or a right parenthesis. And then, of course, those square brackets mean you're listing a range of values. In the regular expression, a quick peek at regex 101 would tell you that. So there's a literal. And let's see here. And anything else other than a white space. So basically any other. I want you to call that an error and then print an error message, right? Because it's possible to have, for instance, a quote, an unterminated quote, and then you have the end of file afterwards. That would be an error, right? So yeah, so I think this is the state diagram that would go along with this this thing. And I need to go to a meeting, and I will say a little bit more after my meeting. Can I zoom out? Yeah, there we go. So if you want to screen capture or what, maybe I'll post this to Piazza, but I have to stop